So welcome to Space Access 2013, my favorite conference. It's changed some. I'm one of the only people who brought hardware that has actually flown. In years past at Space Access, sitting at the bar, I wasn't the only one with a rocket engine in front of me that had actually flown. But this year, I think I'm the only one who brought flown hardware. And the flown hardware is, I debated not coming this year because I worked on things other than hardware this year. I worked on doing some business planning. I worked on some other non-space projects. And as a result, this is pretty much the only experiment I flew. Last year, I flew this, which is a canard nose cone control, about 5 times, and never got good control above supersonic. At about Mach 1, the controls reversed and rolled due to shock waves, and it never really worked very well. So, I switched over to doing 3 gimbaled motors. So this vehicle, on the first flight, it was a total loss. One of the motors burned through, blowtorched my electronics, destroyed my parachute recovery bay, and I brought home pieces with a shovel. So I rebuilt exactly the same vehicle, minus these little trailing edge fins. I flew that in February, and it worked reasonably well, up to about 200 knots of airspeed, and then it started rolling. And so last Saturday, I flew it with these little fins added to try to control the roll, and that worked well. And next weekend, I'm going to have the fins control pitch and yaw, not just roll, and add the GPS to the front end, and we're going to fly it again probably Saturday at Friends of Amateur Rocketry.
Oh, that's right. Can you tell me about the sort of different materials that you've used that might not necessarily be traditional, but have been able to work well, surprisingly?
I don't know. I mean, my first set of automated valves were made from drill motors, like battery-powered drill motors. Got a nice little gearbox, nice little motor. They're light, they're relatively power efficient. So the first set of valve actuators I built for some of my liquid rockets were built from drill motors. This is, there's nothing spectacular here. This is all model airplane and model rocket technology in that, I've got pretty hefty model robot servos up in the front controlling the pitch of the 3 motors, and I've got model airplane wing servos operating the little flaps. The only thing truly unique is this is the little computer that runs everything. There's one just like it buried up in the nose under all the wires. This is of my own design. It's a CPU, IMU, and a magnetometer, and we may turn that into a product, we may not. I've built about 15 of them.
In the past, you were doing work on VTVLs. Are you planning on doing any more work in that area?
I did the VTVL for the Lunar Lander Challenge. Okay, so I'm going to gore some sacred cows. I don't believe there's much of a market for suborbital stuff. I believe it's more of a show-off thing where, I don't see suborbital tourism being huge. I don't see suborbital science being really huge, although I've changed my mind a little bit. There's some more market there than I probably would have originally guessed. I think the real market is all orbital. I mean, orbital is useful commercial service. And so, VTVL is cool and looks like Buck Rogers, but you're not going to build a VTVL orbital vehicle. It just, the physics doesn't work. And while I could make really cool VTL vehicles that might go to 100,000 feet or maybe even 100 kilometers, the market for that is artificial, created by the NASA Flight Opportunities Program, and not long term. And I see no point in VL, vertical landing. I see no point in it long term, because what you want to do is get to orbit. And to get to orbit, I think vertical takeoff is the correct thing, and vertical landing might be interesting for recovery. I've done vertical landing. I've proved I can control and hover a vertical landed vehicle. I have not yet proved I can control a supersonic vehicle through transonic. I have not yet proved I can stage a vehicle well, and those are the things that are on my to-do list to retire more risks.